Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question in which we have to find out the value of intrinsic resistivity, okay, in a semiconductor. So the question is, the intrinsic carrier concentration of a semiconductor is given 2.5 into 10 to the power 16 per meter cube. Okay, intrinsic carrier concentration is given 2.5 into 10 to the power 16 per meter cube at 300 Kelvin, and the electron and hole mobility are 0.15 meter square volt per second and 0.05 meter square volt per second. So we have to find the intrinsic resistivity. We have to find out the intrinsic resistivity, okay, of the semiconductor in kilo ohm meter at 300 Kelvin. Charge of the electron is given 1.6 into 10 to the power minus 19 coulomb. Okay, and the options are 1.65, option B 1.25, option C 0.85, and option D 1.95. So the as we know the intrinsic resistivity formula, okay, I will share the theory behind the intrinsic resistivity calculation theory in the description menu that I have made a video to find out the intrinsic resistivity formula or the relationship between the intrinsic resistivity, electron mobility, hole mobility and density of the electron and hole and current density. I will share the theory in the description menu. So directly I am writing the intrinsic resistivity, that is our rho. Okay, intrinsic resistivity can be written as rho, and it is simply 1 upon q, and we have to write n the electron density into mobility of electron plus hole density into mobility of hole. Okay, this one is the formula. 1 upon this, 1 upon, okay, where q is the charge on the electron, and I am writing here where, okay, n is the electron density. N is the electron density having unit per centimeter cube, okay, or we can write it per meter cube, okay, anything, okay, or we can write it per meter cube here because everything is in meter. So I am writing the electron density having unit per meter cube, and P denote the what, hole density, okay, silicon crystal having the hole density, say we can say P. It is also in, oh, okay, but in the question there is no information about the electron density and hole density. So we have to take the, from the law of mass section, Np equals to Ni square, as we know. Okay, so we have to consider the N and P having the value same as that of intrinsic carrier concentration. So here we have to assume that the electron density and hole density will be same as that of Ni. Okay, so this Ni is given is nothing but simply intrinsic carrier concentration. Okay, so this Ni is nothing but simply N and P having unit centimeter. Okay, so this rho value can be modified as 1 by q. Instead of n we can write as Ni mu n plus Ni mu p. Okay, so rho value can be written as 1 upon q Ni mu n plus mu p. I will share the theory behind this, or I will try to cover in this video also. Okay, so this one is the formula. First, we are just so the value. Now we have to put the value. So as we know, this one is one. Okay, I am selecting some different color. 1 upon Q. Q value is 1.6 into 10 to the power minus 19. Okay, and the Ni value is given in the question. Ni value, see here. Okay, first I have to write the given thing. Ni value, the intrinsic carrier concentration is given 2.5 into 10 to the power 16 per meter cube. The mu n value is given 0.15 meter square volt second, and mu p is 0.05 meter square. Okay, so these are the things is given. Okay, these three things are given. Okay, so now the overall formula is now this, we can say, because electron density and hole density is not given separately, so we have to take from the law of mass section np equals to ni square, and we have to assume n electron density and hole density is nearly equal to the intrinsic carrier concentration ni. Okay, so then after we have to solve this one, simple calculation is there. Okay, you can also write the unit. Okay, and this should be our ni value is how much? 2.5 into 10 to the power 16 into mu n plus mu p. So 0.15, 0.15. Okay. So what we can write? 1, 1.6 into 2.5 into 10 to the minus 19 and 10 to the power 16. So it will be 10 to the power minus 3 into 0.2. 0.15 plus 0.05, 0.2. So if we solve this one, we can write as 10 to the power 3, okay, at the top, and 1.6 into 1 2.5 into 0.2. If we do the calculation, it will come nearly 0.8. Okay, so it should be written as 1 upon 0.8 is nothing but simply 1.25, and this 10 to the power 3 is nothing but simply kilo, and its unit will be ohm meter. Okay, so this one is the answer, 1.25, because in the question they are asking the resistivity in terms of kilo ohm meter. Okay, so this one is the formula, sorry, final result. So means if you have doubt in the unit, you can directly write the means unit. For example, for this one, for the unit purpose, I'm just okay, cube. So make it cube, and ni having unit what, 1 meter cube per meter cube. Okay, clear. Then mu n plus mu p, unit will be mu n plus mu p, unit will be simply meter square volt second. Okay, means because this value will be 0.15 meter volt second plus 0.05 meter square volt per second. So we can write as 0.20 meter square volt per second. So I directly writing this. So this one and this one will be cancelled out. Okay. Then 1. Q is nothing but simply I into T. We know Q equals to current into time. Okay. And then meter will be there only. Okay. And it should be 1 upon volts. Okay, so t and this second, t t equals to second. Okay, time in seconds, so it should be cancelled out. And I by v is what? We know v equals to ir, so I by v is 1 by r. I upon v is 1 by r, 1 by r. So it is in the above, we can write as ohm, and this meter will be go up, so the unit will be ohm meter. Is it okay? So like that we can say this n This 10 power 3 we have written as kilo ohm. So kilo ohm together 1.25. So this one is the means about the unit. Is it clear? Unit part. Okay. Unit part is clear. Unit calculation. This one for the unit calculation. Okay. Now suppose the theory means I have used the formula directly, but some theory I will also give in the description. But also now I will write. So the very fundamental formula, the V drift. As we know, the V drift is nothing but simply mu p e for the positively charged hole. Okay. So in a semiconductor, the carrier drift, the movement of electron and hole due to applied electric field is given is given by the V drift velocity will be mu p e, where this one is a positively charged holes. Okay, for the positively charged holes which are drift along the direction of electric field. Similarly, for the field drift, okay, for the electron, for the hole, we can write it mu n e. Okay, and if we assume that electron density is represented as what n in, in per centimeter cube. Okay, and hole density in a crystal, silicon crystal, is denoted by p in per centimeter cube. Okay, and the charge as well as the density. Okay, charge and the density. For example, qp, the the whole positive charge density. We can say the positive charge density of the or whole density with charge. Okay, if we multiply with the velocity, that is our mu p e. Okay, for a cross sectional area a, it is nothing but simply the current flowing through the like current flowing through the semiconductor. A detailed video I will share. For a applied voltage, there will be some electric field. So holes will be moved like this. Electron will be just opposite to the electric field, and then QP is the what? Positive charge density. Okay, the positive charge density, whole charge density we can write whole charge density mu p e into a. So if we find I by a, that is our current density, is qp mu p e. This one for the whole or jp we can write. Similarly, we can write. I will also give the detailed theory for the electron. Okay, Jn is nothing but simply Qn mu n E is the electric field. So overall J will be Jn Jn plus Jp. Okay, that is our Qn mu n E plus Qp mu p E. So this one is our current density. Current density. Okay, I by A. Now, if we divide J by the electric field, it will give the Q n mu n plus Q p mu p. Okay, so this J by E is nothing but simply 1 by rho resistivity. J by E. Okay, current density by electric field. Current density by electric field. This one is electric field. So it should be what? Q n mu n plus p mu p. So rho will be 1 by q n mu n plus p mu p. Okay. A detailed theory I will give in more detail in our description menu. Okay. So like that we can say the p value rho value will be 1 upon q mu n n plus p mu p, N is the electron density, P is the hole density, mu is the mobility of the electron, mu P is the whole of the whole mobility. Okay. But when there is no electron and hole density is given, we have to take N equals to P equals to intrinsic carrier concentration. This Ni intrinsic carrier concentration. Okay, so a detail of this theory is also I will provide in the description menu. So this is all about this video lecture. This one is the simple question, but somehow we have to remember the formula. Okay, this rho equals to 1 by q, and so this rho and some formula like different formula like rho equals to nothing but simply the J by E is 1 times, so sorry, 1 by rho. Okay, electric field by current density is also some formula that we have to remember. Okay, so this is all about GATE 2025 EC question. So thank you for watching this video. Thank you.